Okay, so pause the video if you need to, but 6.2, solving systems by substitution. So again, there are 3 steps doing this. You get a variable alone. You're going to have 2 equations. So it's kind of like what we did with graphing. You're going to have 2 equations. You're going to figure out where they cross, but we're going to learn how to do this with algebra rather than a graph. So the first step, you get a variable alone. The second step, you plug the expression into the other equation, and then the third one you solve, and then you figure out x and y. So we're going to jump right in. Notice in part A we have 2 equations. We have y equals 2x plus 7, and that one, we have that solved for y. So this is y is 2x plus 7. The other equation, I'm going to take this equation. It is y equals x minus 1. And you might say, why did you put in parentheses and not write y? Because in that other equation, I'm going to take that 2x plus 7 because that equals y, and I'm going to do what we call substitution. I'm going to substitute 2x plus 7 in for y because 2x plus 7 is y. Now, I have to solve for x. So now it's just a basic equation. I'm going to subtract x from each side. I get x plus 7 equals negative 1. I subtract 7, and I get x equals negative 8. Now in part A, I've just figured out x, but now I have to figure out y. To figure out y, I have to take that value of negative 8, and I have to substitute it back in. So I'm going to put it back in here. 2 times negative 8 plus 7 would be negative 16 plus 7, which is negative 9. And that's my value for y. So that's where the 2 lines should cross. All right, we're going to look at part B. Part B has 2 equations. Now the first thing you have to do is you have to solve, and you have to get one of the variables by themselves. If we look at these 2 equations, this second equation almost has x by itself. If I subtract 3y, I will get x equals negative 3y minus 7. So you can get either of the variables by itself. I know in the last one we had y by itself, but this one we have x by itself. Now that x is by itself, x is the variable you're going to take and remove from the other equation. So you go 6y plus 5x equals 8. The reason I took x out is because x is what I'm going to substitute for. So instead of x, I now replace it with what I figured out, 3y minus 7. Now this is a little harder algebra that we're starting here. So you now have to take this and you go 6y plus, we'll distribute 15y minus 35 equals 8. These are like terms. We get 21y. We're going to add 35 to each side. Equals, I messed this one up. 15y minus 35 equals 8. Equals 43. This one must have some sort of a mistake in it. Okay, so we're going to just take that one, and I'm not going to use that one. It maybe works out to be a fraction. Oh, let's finish it. You might get some with a fraction, so I will. So this one ends up being y equals 43 over 21. That's kind of a strange value for y. Now we put it back into this. 3 times 43 over 21. Notice I'm putting it in for y. Minus 7. I'm going to do this one in the calculator since it ended up kind of goofy. Multiply by 43 over 21 minus 7. Oop, I did that wrong. I'll redo it. 3 outside of the parentheses, we get negative 6/7. So the solution to this one, this would be x equals negative 6/7 and 43/21. Kind of a strange plot, but we did have some in the graphing ones that turned out to be decimals. You could make those decimals as well. All right, so this one, we have x equals something already. We have one of the variables by itself. So x is the variable you're going to take out of the second equation. So I take out x. Now this is something that some students struggle with a little bit. Because x is by itself, go to the other equation, take out the x. Now put in what x equals. X equals negative 3y plus 4. Now it's simple algebra. We multiply 6y minus 6y plus 8 equals 8. 6y minus 6y would disappear. We get 8 equals 8. This one, because the variables disappear, that same rules apply that we've had all year. That has infinite many solutions. Infinitely many. All right, part B. Y equals 4x minus 9. So in the other equation, I'm going to take out y. So after taking out y, I have 4x, subtract 9. 4x, subtract 4x. Those eliminate each other. We get negative 9 equals 6. So this one we have two different answers. So this one has no solution. All right, this next one, we have y solved for. So since this equation has y solved for, I'm going to go to the other equation. I'm going to take out y. Instead of y, I'm going to put in what y equals. Y equals 3x subtract 4. Now I'm going to have to distribute. 15x subtract 20 equals 19. Negative 2x plus 15x is 13x. Subtract 20 equals 19. We'll add 20 to each side. 13x equals 39. Divide by 13. X is 3. We've solved for x, so we can take what x is and we can put it back in for x. 3 times 3 is 9. Subtract 4 is 5. When x is 3, y is 5. That's where these two lines would cross. Last one in this lesson. I'm going to look at this equation. I'm going to add 2y. The reason I'm going to do that is x is almost by itself. So again, one of the things you first have to do is you have to get a variable by itself. Then the second step, you are going to substitute. So we're going to take x out here. And we're going to substitute 2y minus 6 combine like terms. 14 and 3y give us 11y. Subtract 42 is 2. We'll add 42 to each side. 11y equals 44. Divide by 11. Y is 4. So we had y is 4. Now take that 4, put it back into your equation over here. We put 4 in there. 2 times 4 is 8. Subtract 6 is 2. X will be 2. That's our solution.